Somewhere out past the edge of everything we've ever mapped, something massive appears to be quietly bending the orbits of dozens of distant objects, all in the same direction, all at once. Nobody has ever seen it. Nobody has ever photographed it directly. And yet a growing number of the world's leading planetary scientists are telling NASA that it is now harder to explain the outer solar system without it than with it. Stick around, because I'm about to walk you through exactly what the evidence for Planet 9 actually says, what NASA has and has not actually confirmed, and why the next few months might finally settle this question for good. And hit subscribe now, because this channel breaks down real published research without the exaggeration, and you do not want to miss where this story goes next. Before we get into the modern case for this planet, it's worth clearing something up right away, because it matters for understanding the rest of this story. The idea of an undiscovered world hiding beyond Pluto is not new. It has haunted astronomy for more than a century, and the first version of it turned out to be completely wrong. Back in the early 20th century, astronomer Percival Lowell became convinced that something was tugging on the orbits of Uranus and Neptune, pulling them very slightly off the paths that Newtonian physics said they should be following. Lowell called this hypothetical world Planet X, and he spent the final years of his life searching for it from his observatory in Flagstaff, Arizona, without success. The search continued after his death, and in 1930, a young observatory assistant named Clyde Tombaugh finally spotted a faint moving object on a photographic plate. That object became Pluto. For decades, Pluto was treated as the answer to Lowell's original question, at least until later, far more precise measurements revealed something awkward. Pluto was simply too small, by a wide margin, to have ever caused the orbital wobbles Lowell thought he was seeing in the first place. Eventually, scientists determined that those original discrepancies in the orbits of Uranus and Neptune were never real. They were measurement errors, byproducts of slightly inaccurate estimates of Neptune's mass, not evidence of any hidden planet at all. The original Planet X was, in the end, chasing a mistake. That should have been the end of the story. Instead, something strange happened decades later when astronomers went looking at a completely different part of the solar system for a completely different reason, and ran into a pattern that looked suspiciously similar all over again. If you're the kind of person who wants space stories explained clearly instead of buried under jargon, go ahead and drop a like on this video right now, because it genuinely helps this kind of content reach more people who would enjoy it. The modern story really begins with the Kuiper Belt, the vast ring of icy debris beginning just beyond Neptune's orbit, home to Pluto and hundreds of thousands of other small, frozen bodies. In 2003, astronomer Mike Brown at Caltech discovered a strange distant object he named Sedna, notable because, unlike a normal Kuiper Belt object, its orbit never brings it particularly close to Neptune at all. In 2014, another team, led by Chad Trujillo and Scott Shepard, discovered a second object with a similar kind of detached distant orbit called 2012 VP113. And that same year, Trujillo and Shepard noticed something odd while comparing Sedna 2012 VP113 and roughly a dozen other extremely distant Kuiper Belt objects side by side. An obscure orbital feature related to the direction each object's orbit pointed in space seemed to line up across all of them far more consistently than random chance should allow. That observation caught the attention of Brown and his Caltech colleague, Konstantin Batygin. Together, they modeled what could possibly cause that alignment, and in a paper published in the Astronomical Journal in January of 2016, they proposed an explanation. A large undiscovered planet, orbiting far beyond Neptune on its own extremely elongated path, could gravitationally herd smaller, distant Kuiper Belt objects into exactly this kind of shared alignment over billions of years. They gave this hypothetical world a name, Planet 9, deliberately distancing it from Lowell's discredited Planet X, since this new hypothesis had nothing to do with the debunked orbital wobbles of Uranus and Neptune. It was built entirely from a completely different and considerably more robust body of evidence. According to Batygin, when the team first started running the numbers, they were genuinely skeptical that a planet like this could really be out there. In their own words, published alongside the original research, the more they investigated what the object's existence would actually mean for the outer solar system, the more convinced they became that it had to exist. Brown, reflecting on the broader implication of the discovery, described it as the first solid evidence in more than a century that our solar system's planetary census might genuinely be incomplete. Here's where the case has grown considerably stronger in the years since that original 2016 paper, and where NASA itself has weighed in directly. According to a NASA statement on the subject, Batygin has said that there are now 5 separate, independent lines of observational evidence, all pointing toward the same conclusion. Removing Planet 9 from the picture entirely, he argues, does not simplify anything. Instead, it leaves scientists needing 5 completely separate explanations for 5 different unusual features of the outer solar system, rather than one single unifying cause. The first of those 5 lines of evidence is the original clustering, the way roughly a dozen distant Kuiper Belt objects share a suspiciously similar orbital orientation. The second involves several objects, including Sedna, orbiting on paths that are unusually tilted relative to the flat plane where most planets in our solar system orbit, a tilt that a distant massive planet's gravity could plausibly explain over enough time. A third and particularly striking piece of evidence, developed by Batagen's graduate student Elizabeth Bailey, suggested that Planet 9's gravity could even help explain a long-standing oddity of our entire solar system. The fact that the Sun's own spin axis is tilted several degrees relative to the orbital plane of the planets, something that becomes easier to explain if a massive object has been quietly tugging on the whole system from far outside it for billions of years. Additional lines of evidence involve specific, unusual orbital tilts among certain other distant Kuiper Belt objects, patterns researchers say are difficult to produce through any known process other than the gravitational influence of an additional, unseen planet. Based on these combined lines of evidence, current estimates place Planet 9 at roughly 5 to 10 times the mass of Earth, likely making it a super-Earth, a class of planet more massive than our own but smaller than gas giants like Neptune or Uranus, a type of world that, notably, does not exist anywhere else in our own solar system, but appears to be extremely common around other stars throughout the galaxy. Current models suggest it would orbit at an average distance somewhere around 20 times farther from the Sun than Neptune itself, putting it hundreds of times farther from the Sun than Earth is, on an elongated path that could take somewhere between 10 and 20,000 years to complete a single orbit. If you have found this as fascinating as I did while researching it, drop a comment letting me know, because it genuinely helps me figure out what other space stories are worth covering next. This is exactly where we need to be honest about something important, because it's the part that a lot of headlines, including titles very similar to this video's, tend to blur past. NASA has not confirmed that Planet 9 exists. As of today, no telescope, anywhere on Earth or in space, has directly photographed it, tracked its motion across the sky, or confirmed its presence the way every other planet in our solar system has ultimately been confirmed. What NASA's own public statements describe is mounting circumstantial evidence, a genuinely compelling case built from gravitational fingerprints rather than a direct sighting. That distinction matters enormously in science. A gravitational signature can, in principle, still turn out to have some other explanation nobody has thought of yet, and a number of serious researchers remain genuinely skeptical of the entire hypothesis for exactly that reason. That skepticism got a significant boost very recently. In June of 2026, astronomers using the Subaru telescope in Hawaii announced the discovery of a new distant object, a type of body called a sednoid, nicknamed Ammonite. According to researchers studying the discovery, Ammonite's orbit does not fit neatly into the same clustered alignment that originally helped inspire the Planet 9 hypothesis back in 2014. Because Ammonite is misaligned compared to the pattern researchers expected, its discovery has actually weakened one of the original pillars of evidence for Planet 9. Rather than strengthening it, a reminder that this remains a genuinely live, unsettled scientific debate rather than a closed case. At almost the exact same time, a separate and considerably more tantalizing lead emerged from an entirely different direction. A team led by astronomer Terry Long Fan, working with researcher Tomotsugu Goto, took a different approach entirely, going back through old infrared sky survey data rather than searching for new gravitational clues. By comparing images from NASA's IRAS satellite, which scanned the sky back in 1983, against images from Japan's Akari satellite, which surveyed the sky more than 2 decades later between 2006 and 2011, the team searched for a faint object that had moved position between the two surveys, the exact same basic technique Clyde Tombaugh had used to discover Pluto nearly a century earlier, just carried out with modern infrared data instead of visible light photographic plates. According to Fan, they did find a candidate object that shifted position between the two surveys in a way broadly consistent with a distant planet. Based on its brightness in those images, Fan has estimated that if this object really is Planet 9, it would likely be more massive than Neptune itself, a genuine surprise, since the team had originally been searching for something closer to a smaller, super-Earth-sized body. It is important to note that this candidate remains exactly that, a candidate, not a confirmed detection. Fan has publicly stated that the object could not be located in a separate, more recent dataset from NASA's WISE satellite, since without a confirmed orbit, researchers cannot yet calculate precisely where it should have moved to in the years since the Akari survey was taken. Previous surveys using WISE have already ruled out the presence of any Jupiter-sized planet out to an enormous distance from the Sun, and any Saturn-sized planet out to a very substantial distance as well. But researchers say a smaller Neptune or Uranus-sized world could plausibly still have gone completely undetected in that same data. Picture, for a moment, what it would actually mean to stand near a planet like this, if it truly exists, out where current models suggest. At a distance hundreds of times farther from the sun than Earth is, sunlight reaching that world would arrive so weak and so faint that our own sun would appear as little more than an unusually bright star hanging in an otherwise pitch-black sky, rather than the warm, glowing disk we're used to seeing from Earth. Temperatures would sit at almost unimaginable extremes, hundreds of degrees below zero, cold enough to freeze essentially every gas we're familiar with solid. An orbit lasting 10 to 20,000 years means that if such a planet exists, it has completed only a tiny handful of full trips around the sun since the earliest human civilizations first began building cities, and it would not complete a single one during the entire span of recorded human history so far. It would be a world moving so slowly across our sky from Earth's perspective that centuries could pass with almost no perceptible change in its position at all, one of the reasons it has proven so extraordinarily difficult for any telescope to definitively track down. There is, finally, a genuine reason for real optimism that this decades-long question might actually get answered soon, and it does not come from a single research team's model or a single archived photograph. It comes from a brand new telescope, the Vera Rubin Observatory, a joint project of the National Science Foundation and the Department of Energy, built in Chile specifically to repeatedly scan the entire visible night sky over and over across a period of roughly 10 years, began issuing its first public data alerts in February of 2026. According to Batigan, speaking about the observatory's potential to finally settle this question, the Rubin Observatory is expected to begin producing a substantial new batch of outer solar system discoveries starting this summer. And he has described this moment as a direct test of every line of evidence gathered so far in support of Planet 9. If a planet matching the predicted mass and orbit genuinely exists out there, an observatory built specifically to repeatedly photograph the entire sky in extraordinary detail represents, according to the researchers involved, one of the best realistic chances yet of finally catching it directly, rather than continuing to infer its presence purely from its gravitational effects on smaller, already known objects. It's worth being clear-eyed about what would happen either way, because both outcomes would be genuinely significant for planetary science. If the Rubin Observatory or a future infrared survey manages to directly image and track a new massive planet in the outer solar system, it would represent the first confirmed planetary discovery in our own solar system in nearly 2 centuries, since Neptune was first identified in 1846. If, instead, years of continued deep sky surveys turn up nothing at all, researchers will be forced to go back and find an entirely different explanation for the 5 separate lines of evidence Batigan and others have spent the past decade building, along with the newly complicating discovery of objects like ammonite that don't fit the original pattern cleanly. Either result would meaningfully reshape our understanding of the outer solar system. That tension, a genuinely open scientific question with strong evidence on multiple sides and a powerful new tool finally capable of testing it directly, is exactly why this remains one of the most actively debated topics in planetary astronomy today. So what does all of this actually add up to? More than a century after Percival Lowell first went searching for a hidden world beyond Neptune based on a mistake, astronomers find themselves chasing a strikingly similar question again, this time built on a genuinely different and considerably stronger foundation of evidence, gathered from the orbits of dozens of real, confirmed objects rather than a single miscalculated wobble. NASA has not confirmed that Planet 9 exists. What NASA has confirmed is that something in the outer solar system continues to behave in ways that are extremely difficult to explain without one, and that the tools, now coming online, may finally be powerful enough to settle the question either way within the next few years, rather than the next few decades. Whether the answer turns out to be a genuine 9th major planet hiding in the dark beyond Pluto, or a more mundane explanation nobody has fully worked out yet, the outer solar system has once again proven that we do not yet have the full map of our own cosmic neighborhood completely figured out. If stories like this one, grounded in real published research rather than exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications, because the Rubin Observatory is only just getting started and there is a real chance the next update on this story is the one that finally settles it, one way or the other. Thanks for watching, and I will see you in the next one.